In section 6 of chapter 11, we are now going to start discussing what are called trig identities. Now, you already know quite a few of the trig identities. In fact, you know the foundational basic level trig identities. But I will forewarn you, in pre-calculus, the trigonometry section is largely broken into two parts. One is the unit circle and its applications. The other, which kind of ties the unit circle and the applications, is on trig identities. Trig identities are something that you are going to have to memorize. There's a lot of them. I am just showing you the ones that are the most prevalent in trigonometry, but there are more that you will have to learn. First, I want to go over the 6 trigonometric identities that you know thus far. Technically, the first 2 aren't trig identities, but I still like to write it up here. We know about sine of theta. We also know about cosine of theta. Those 2 are technically not trig identities. Those are the basic 2 trigonometric functions. We also know tangent of theta. However, tangent is equal to something else. It is equal to sine of theta over cosine of theta. That, what I just wrote in green, is a trig identity. It is something equal to something else. They have the same identity. So if you ever see a tangent in a long equation or expression, you could swap it with sine over cosine, and you're not changing the value of the equation or expression, you're just rewriting it in a different format. So that is considered a trig identity. Next, we have cosecant. Cosecant of theta. Cosecant of theta is equal to 1 over the sine of theta. That is also a trigonometric identity. And then next, we have secant of theta. Secant of theta is 1 over the cosine of theta. Again, that is another trigonometric identity. If you ever see a secant in an equation or an expression, you can replace it with 1 over cosine, and you will be able to manipulate in that capacity. And then the last one of the 6 that we know is cotangent of theta, which technically has 2 different identities. Cotangent could be written either as 1 divided by tangent, or it could be written as cosine divided by sine. So this one's kind of a 2-parter. Depending on the circumstance, one of those 2 identities might be more or less useful than the other. What we are going to be doing in this lesson is utilizing these identities to simplify expressions that have trigonometry in them. So here are my first set of problems. Problem number 1, I have the tangent of theta times the cosine of theta. Now, while that looks relatively nice and pretty, this is simplifiable. It is simplifiable because I could rewrite tangent as sine of theta over the cosine of theta. And why might I want to do that? Because that's cosine of theta over 1. And whenever I have the same value on top and bottom of 2 fractions being multiplied to one another, they can cancel. Meaning that original problem, tangent of theta times cosine of theta, it would be much easier to write its simplified form as just sine of theta. Problem number 2. I have sine of theta divided by secant of theta times cotangent of theta divided by cosine of theta. Now you will learn, kind of what I did in the first problem, that one of the most fundamental steps you can take when simplifying trigonometric expressions is turn everything into sines and cosines and find what cancels and what doesn't. So I am going to turn this into sine of theta divided by 1 over cosine of theta times cotangent is cosine of theta over sine of theta divided by cosine of theta. Now, some of you might be able to cancel this stuff right off the get-go. I'm not that smart. I don't like fractions inside of fractions, so I'm going to convert that. When I'm dividing by a fraction, I can do that by multiplying by the reciprocal. So that's just going to be sine of theta times the reciprocal of 1 over cosine, which is cosine, times cosine over sine, times 1 over cosine. Those first two parts have denominators of 1. And now all I'm going to do is cancel things on top and bottom that are the same. I have a sine on top. I have a sine on bottom. I have a cosine on top. I have a cosine on bottom. The only thing that's left is a cosine on top. So the answer is cosine of theta. Problem number 3 is when we start dealing with division, but also exponents. I have tangent cubed divided by cosine divided by sine squared over secant to the 5th. I'm going to do two things at once. One, I'm going to flip and multiply what I'm dividing by, because whenever you're dividing by a fraction, you can multiply by the reciprocal. But I'm also going to turn everything into sines and cosines. So this is going to be equal to, tangent is sine over cosine, so this will be sine cubed of theta over cosine cubed of theta, over cosine of theta. And I'm going to switch the division to multiplication, and I'm going to flip this second fraction. So the secant is going to be on top, the sine is going to be on bottom. But secant is the same thing as 1 over cosine. So this is 1 over cosine to the 5th power theta over sine squared of theta. And just for my brain, I like it better if I write it just as a solid string. So the first fraction, I'm going to write the sine cubed over cosine cubed is just one fraction. Sine cubed over cosine cubed. I'm dividing by cosine, which is the same thing as multiplying by 1 over cosine, times 1 over cosine to the 5th, and then times the reciprocal of sine squared, which is 1 over sine squared. All right. Turned everything to sines and cosines. Got it to just be fraction times fraction times fraction times fraction. Now that I have it written in this form, I can cancel, eliminate things on top and bottom that are the same. All right. I have 3 sines on top, and I've got 2 of them on bottom. These 2 will eliminate with 2 of the 3, leaving with just 1. And that's all that cancels. Meaning this is equal to sine of theta over, I have 3 cosines on the bottom in the first part, another 1 in the second part, and then 5, so 5, 6, 7, 8, 9. I have 9 cosines on bottom. I am okay with this as an answer, but I would like you all to also realize that that is the same thing as sine of theta over cosine of theta times 1 over cosine to the 8th of theta, which is equal to tangent of theta times the secant to the 8th power of theta. I'm okay with you not converting it into that format. I'm okay with you leaving it as sine of theta divided by cosine to the 9th of theta, but you should be familiar with how to convert it back into tangent and secant, because on multiple choice tests or simplification tests or your pre-calculus test, they will expect you to take this step later on. On my last 2 problems, I want to deal with addition and subtraction. So we are going to simplify each of these into monomials. I want to simplify these from something plus something, a term plus another term. I want to condense that into a single term. Now, while in reality, this is not a process that we do a whole heck of a lot of in mathematics, this is a skill that is going to help you in future concepts where you're going to have to learn how to add and subtract terms with trigonometric values in them. So you can kind of think about this as kind of a little bit of practice for a later skill we're going to learn. So problem number 4, I have secant of theta divided by sine of theta plus tangent of theta. Technically, I'm taking two fractions and adding them together. Remember, tangent is a fraction. It's sine over cosine. In order to add two fractions together, you need to have the same denominator. So first, in order for me to get the same denominator, I need to turn everything into sines and cosines. So problem number 4, that is going to be secant is 1 over cosine divided by sine plus sine over cosine. I don't like that I have a fraction on the top, but when I combine those together, I'll get 1 over cosine of theta times 1 over sine of theta plus sine of theta over cosine of theta. Then I can multiply the very first two things together. 1 over cosine times 1 over sine is 1 over cosine of theta sine of theta plus sine of theta over cos of theta. So I converted everything into sines and cosines. And then I simplified it as much as humanly possible for each individual term. Now I've got a fraction plus a fraction where everything's in terms of sines and cosines. I can combine these together using the same process we did when we had two fractions with numbers in the denominators. We got to get a common denominator. The first fraction has a denominator with a cosine and a sine. The second fraction has cosine. It is missing the sine. So I'm going to multiply the second fraction by sine over sine. That will allow me to then have 1 over cosine of theta sine of theta plus sine squared of theta over cos of theta sine of theta. Now that those two fractions have the same denominators, I can combine them together with the numerators. This is going to be 1 plus sine squared of theta over cosine of theta sine of theta. I often get students to then ask me, Mr. Silva, if we have a sine squared on top and a sine on the bottom, could that square cancel with the sine? No, it cannot. There's addition here. You cannot cancel things on top and bottoms of fractions if addition is anywhere in the numerator or denominator. That is also true for subtraction. Second question I often get is, all right, can we then convert the sine over cosine into a tangent? Same issue as simplifying. You cannot turn sine over cosine into tangent if addition is occurring in either the numerator or denominator. Therefore, this is our final answer. Problem number 5 and problem number 4 are very similar, but they don't look similar because problem 4 had a fraction in it. It was secant of theta divided by sine of theta. Problem 5 has fractions in it. It's just not easily observable in the format that it is currently written in. That is because the first term and the second term have reciprocal trig functions, which means inherently they're already fractions. Cosecant is the same thing as 1 over sine minus 3 over secant is 1 over cosine. In order to combine these two together through addition and subtraction, they need to have the same denominator. The first fraction has a denominator of sine. This one does not have a sine in it. Therefore, I'm going to multiply the second fraction by sine over sine. This second fraction has a denominator of cosine. The first fraction does not, so I have to multiply it by cosine over cosine. That will give me cosine of theta over cosine of theta sine of theta minus 3 sine of theta over cos of theta sine of theta. Now that the denominators are the same, I can simply combine the numerators together through, in this case, subtraction. This is cosine of theta minus 3 sine of theta, all divided by cos theta sine theta. And that is our solution.